Okay, so we started talking about the logarithm rules, just writing logarithms back and forth, and then talking about what happens when you're adding logarithms and when you're subtracting logs. And in the interest of time, I was just trying to keep these videos fairly short. So we're going to do this one as a second lesson. But we're still talking about simplifying logarithms using the basic logarithm rules. Then the next rule you're going to need to know is what happens when you have something times a log, okay, and what that really means. What it means is that you really are just rewriting the log of something with an exponent. We can't work with this exponent here. But what we can do is simply move it in front of the log and make it a multiplier. All right? So it's just going to drop in front. So we're going to look at a few examples of that and then see kind of how it affects our working. All right? So the first thing they ask you to do there on page 22 is to rewrite them as a single number. So, for example, number 2, we have, 3 times the log of 2. Well, you have the number in front of the logarithm. That number, 3, is actually an exponent. Okay, so all that's going to happen is it's going to be log of 2, and that 3 is going to go back and become the exponent on there. And, of course, we can take 2 to the third power. Becomes the log 2 to the third power is 8. So make sure that you simplify it as much as you can. All right? So, pretty easy work. So let's look at number 6. 1 over a log b. This is simply going to become the exponent. So that becomes log of b to the 1 over a. Now, if this was an actual number and it was a fractional exponent, and they may do it anyway, it would become the a root of b. Remember that a fractional exponent actually becomes a root. Okay? And then if these were actual numbers and you could take the root, then you should. Okay? So let's do number 4. It's got real numbers. It's 1/2 log of 49, which becomes log of 49 raised to the 1/2 power, which becomes log of the square root of 49, which becomes log of 7. A little work to do there, just a lot of little pieces putting together, but it finally gets you to some more simplified version. Now, more often than not, you're going to be doing it the other way, where you're putting the exponent in front because it's a lot easier to simplify. But in this case, taking this square root of 49 gave you a much simpler version of the answer. And you can use these rules of exponents and moving the exponents around so that you can simplify to get like bases. Okay? So to get the same, so that you're taking the same logs. So let's look at putting them all together. Sadly, these are some of my favorite problems because the mathematics behind them is not difficult, but they're like little puzzles. So putting it all together means you just have to be very careful. So let's just look at their examples. Again, we're still on page 22. So they have 1/2 log 64 minus 3 times the log of 2. Okay. Well, we can't do anything with those the way they are because we have those numbers in the front that are kind of messing with us. So what we can do is see if we can simplify each one of those logs. And we can, because that becomes 64 to the 1/2, which is the square root of 64, which becomes log of 8. Okay? This one The 3 becomes an exponent on the 2, which becomes log of 2 to the third, and of course 2 to the third is 8. And anything minus itself, no matter what kind of fancy names, words, or anything else it has in front of it, anything minus itself is always just 0. Okay, so you can see by simplifying the logarithms as much as you possibly can, we were able to then just use arithmetic. Let's look at another one. If they have 5 log of 2 minus 1/2 log of 16 all over the log of 32. So what we need to do is we need to see if we can simplify some of these. That becomes log of 2 to the 5th minus this 1/2 becomes the exponent on the 16, the log of the square root of 16 over the log of 32. That one can't change because it was already as simplified as the logarithm can get. Well, 2 to the 5th power is, okay, so 2 to the 5th power becomes log of 32, of 32 minus the log of 16 becomes log of square root of 16 becomes log of 4, all divided by log of 32. And hopefully you know that you cannot simply simplify these two out because of this connection with the subtraction. So you cannot just divide those away. Be careful. But what we can do is simplify the things in the top. Log base 32 minus the log base of 4 is the same as log base 32 over log base 4, or simply log, not base, I keep saying base, I'm sorry, log of 32 divided by 4, which is the log of 8. Okay. Then that's still over the log of 32. We can't divide 8 by 32, so that won't really help us by just looking at it as division, but we can see if we can turn them into the same log by using the exponent rules. And again, I told you the math is not difficult, but there's a lot of manipulations back and forth. So what we can do is turn 8 into the log of 2 raised to the 3rd power. And we can turn 32 into the log of 2 raised to the 5th power. Now those exponents can become coefficients of the or multipliers there. So it's 3 times log base 2 over 5 times log base 2. I'm sorry, not log base 2, log of 2. Now, because these things are multiplied, we can now divide them away. And so the final completed answer is just 3 over 5. Okay? Now we had to do a lot of work to get there, but it's pretty simple. The mathematics anyway. Okay? So let's look at a couple more of these, because this is what you're gonna work on for the rest of this part before we start talking about solving the equations next time. So look at something like, we'll start off really easy. Log base 32 plus log base 8. All right? Now, pay attention to the connecting operation. If that's an addition, if you're adding logs, that really means that you're going to end up multiplying logs. Okay? Now, when you're multiplying logs, many times it's easier to simplify them as much as you can first as exponents, because when you're doing it as exponents, you can just add the exponents. Okay, right? So think about that when you're multiplying these things out. It may make your life a little easier. So that becomes log of 2 to the 5th plus log of 2 to the 3rd, right? And then, now that they're the same, we can move these in front and simply add them together. So we get 5 logs of 2 plus 4, I'm sorry, not 4, 3. 3 logs of 2, and they're the same thing, so we can add 8 logs of 2. Okay, now again, that's because we're multiplying here, okay? But it was easier to say 5 of those same things plus 3 of those same things than to multiply 32 times 8 and then try to simplify that, okay? All right. Let's look at another one. Let's see. Number 5, really good one because it has a twist. Log of 1,000 minus 1/2 times the log of 100. So, in subtracting means we're going to be dividing them. In order to divide them, we want to see if we can simplify these if we at all. And 1,000 can be rewritten as 10 to the 3rd power. All right? Minus, now the 1/2 becomes the square root of that, the log of the square root of 100. Okay? And so that 3 will move up front and become just plain old 3 times the log of 10 minus the log of 10. Now, here's the trick here. Log of 10 and log of 10. It's log base 10 of 10, so those both become 1s. It's a trick. They're being mean to you. So just work it out. So that becomes 3 minus 1, which is 2. Now, in the book, they have 2 log of 10. I do not agree with that one bit because the log of 10 is not anything. The log of 10 is 1. So that is a bad answer. All right. Let's see. We'll just pull up another one. Say we have number 10. Looks nice and ugly. Let's see if we can work it out. 3 log of 2 plus log of 1/8. Notice they put it in parentheses because it's not the log of 1 or the log of 8. It's 1/8, so they had to put the fraction in parentheses. I like this one. Becomes the log of 2 to the 3rd power, which is log of 8 plus log of 1/8. Because we're adding them, that means we multiply these two numbers. So 8 times 1/8. The 8s will divide away, leave you 1. So it becomes log of 1. And log base 10 of 1, or log of base of anything of 1 equals 0. So don't forget those simplified versions, right? If anytime you have the log of 1, that always becomes a 0. Okay? So hopefully these won't drive you too crazy. Just be careful. Like number 14 has some negative exponents. Be very careful about signs and how to make those simplify those exponents. These manipulations are, again, can be a little frustrating, right? Thanks so much. So now what I want you to do is make sure you can do everything from page, where did that start? Page 22 through page 24. Thanks.